Hello everyone, in today's video we will learn about Wien's law, Stefan Boltzmans law, and the luminosity of stars. So let's go right ahead and see Wien's law. So from our last video, we know that hotter objects emit shorter wavelengths. And that colder objects emit longer wavelengths. And so this is an important fact that you have to know. So for Wien's law, the peak wavelength multiplied by the temperature equals a constant. So lambda peak times T, in this case is temperature, equals a constant. And this constant is 2.9 times 10 to the 6 nanometers Kelvin. So this constant helps us figure out the temperature given the peak wavelength, or given the temperature we can find out the peak wavelength. So either way we have this constant, and if we know one or the other we can find out the variable that we want to find out. The Stefan Boltzmans law helps us figure out the energy radiated per unit surface area. So this can be a given planet or star, and we can derive this equation from it. E equals to sigma times T to the 4th power. So sigma is a constant that we can know is equals to 5.670 times 10 to the negative 8th. And this will be in units of, you don't have to memorize this constant, but just know that temperature is related to the energy, or the amount of energy that is produced. So if we increase the temperature, we can see that the energy will also increase. Also, if we compare the energy radiated per surface area of two different planets, we can cancel out the sigma constant and derive just this. So if we say one planet is 6,000 Kelvin and another planet is 3,000 Kelvin, we can say that 6,000 over 3,000 to the 4th is the amount that we're trying to find, and the energy difference. So the ratio would actually be 16 to 1. Last but not least, we want to focus on the luminosity of stars. So instead of calculating the energy radiated per unit surface area, we want to calculate the total energy emitted per second by the entire object. So this would be all surfaces. And this equation is actually adding on to the last one. So we have surface area, let's put SA, multiplied to the energy emitted in the last equation. So we have sigma times T to the 4th power. So whatever the surface area is, so if it's a sphere, we can say that it's 4 pi r squared times sigma to the T to the 4th. And that's usually the case for planets. So it would be 4 pi r squared, r is the radius of the planet, multiplied by sigma T to the 4th, which would give us the luminosity. So in order to figure out the luminosity, all we need to do is find the radius and the temperature, since pi and sigma are constants. And if we have the luminosity and the radius, we can find the temperature of the planet. So 2 variables gives us 1 unknown. Many astrophysicists have the data on the luminosity and temperature, and so they use this equation to derive the radius and see how big planets are. And so this concludes this section of the video. In our next one, we will be talking about telescopes.